Welcome to our video on Newton's laws of motion, the foundation of classical physics. Today, we'll explore these three fundamental principles formulated by Sir Isaac Newton and their implications in understanding the motion of objects. So, let's dive in. First up, we have Newton's first law of motion, also known as the law of inertia. This law states that an object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by an external force. In simpler terms, if you push a stationary object, it will start moving. And if you stop pushing it, it will eventually come to a halt. Likewise, if an object is already moving, it will keep moving unless a force acts on it to change its motion. Narrator. Next, we have Newton's second law of motion, the law of acceleration. This law describes how the acceleration of an object depends on the net force acting upon it and its mass. Mathematically, it can be expressed as F equals ma, where F represents the net force applied to an object, m represents its mass, and a represents the resulting acceleration. Simply put, the force acting on an object determines how much it accelerates, and the object's mass affects how much force is required to produce a given acceleration. Finally, we have Newton's third law of motion, the law of action-reaction. This law states that for every action, there is an equal and opposite reaction. In other words, when an object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. Forces always occur in pairs, acting on different objects but with equal magnitudes and opposite directions. They provide the foundation for analyzing the effects of forces, predicting motion, and engineering countless inventions and technologies. Thank you. Please subscribe to my channel.